So thank you so much for being here. It's our uh, let's say Python-oriented data infra episode today. We're very happy to have Elvis from dltHub. We're being, working and knowing Elvis for many years now. Very excited to finally have a demo together. Ciro is going to present, everything is related to Bauplan, and Elvis is going to demo the DLT part. Feel free, to use the chat to ask whatever question you want. Let's have fun. Let's keep this conversational if possible. Please, guys, stage is yours. I don't know, Ciro?
Check, check. You can hear me, yeah, Matt?
Yeah, I can hear you very, very well.
Cool. Let's wait for Ciro then.
Yeah. I don't know, Elvis, if you want to introduce yourself in the meantime.
Yeah, yeah, hey everyone. My name is Elvis. I do developer relations at dltHub. Um, dltHub is an open source Python SDK, and we're just trying to make it easier for people to work with data. So everything from like extracting data to being able to load it to wherever you want it to go, be it like DuckDB or Iceberg or Bauplan. Yeah, I'm just glad to be here and working in Python.
Thank you so much, Elvis. Please, Ciro, you can. I think you're back.
Do you think I'm back?
Yeah, I think you're
Yes, I am
back.
back. Sorry
Yeah,
about this.
don't worry about it. I think we can get started.
Strange snag. Okay. So if I can share my screen, I should be able to see
Yeah.
my screen. Yeah. Um, yeah, as I was saying, I was actually like I'm pretty excited about this because like I like what you guys are doing at dltHub, and I've been following you for a while. And like this idea of having like everything like super Pythonic and very programmable, I think is particularly well suited for this era. So we've been focusing a lot on this, like both at Bauplan, I think, and dltHub. So like a lot of what we're going to talk about is basically how you want to keep like bringing like AI agents in your data workflows, and how you can have like infrastructure that is designed precisely for this, and it's kind of like born in this specific era, and has a bunch of like ergonomics for AI agents to do this. We ultimately kind of like want to use AI agents on our data work as data practitioners. So like what you see here is very similar to the prompt that we are going to be using in the demo. And so when I see that, I mean, when I see like a prompt like this, I mean, like I see like the possibility of using an AI agents to do a lot of the work that typically you do as a platform engineer, as a data engineer, as a data scientist, and like as a data practitioner at large. And we also kind of like want to have, a way to just like have agents be able to manipulate and access data, because like that just like makes agents smarter. We have customers and people that are using now our infrastructure, for instance, to get agents and do things that at a certain point in the workflow will require a touch point with data. Like for instance, like if there's something that goes wrong and you want to do a root cause analysis, fix it, or deploy a new feature and so on. The problem is that like when you usually touch data, we all want to avoid kind of like disastrous scenarios where the agent is left unchecked with playing around with your data. I think like most of the folks that we talk to have a kind of like a dual experience where you have like a lot of agentic workflows when you write your code and you work with your code locally. And then the moment you kind of like hit the cloud infrastructure and you have to do more work that is specifically touching the production data, everything kind of needs to slow down, and we have to think more carefully about how we architect the whole thing and how we think about the agent interacting with the data.
Ciro,
G
we have a kind of, I think, a pretty cool like warming up question.
Cool. Go
It's
ahead.
here in the chat. I think it's a pretty common like consultancy problem. And say my
Hmm.
client is asking me to use AI pretty much everywhere, but at the
Yep.
same time, they have a data stack that is basically coming straight from like, uh, I don't know, like Stone Age. What should
Okay.
I do?
Okay. Define Stone Age. Like we're talking about like IBM
I don't know.
mainframes.
I
We're
don't
talking
know.
about. Okay.
Say
Uh,
prehistoric stacks. Stone Age is
no.
Synapse. Okay.
So I think yeah, so there's several questions usually when you want to bring like agents into the mix that are regarding more like the architecture and how you actually have your setup. I think like right now, kind of like the moment where we live in provides some kind of like shortcuts to do that. Like you have the possibility of doing essentially what I would advise is to convince them to do like data lake design where your entry point for your agent to be able to manipulate things in the cloud is somewhere, some object storage. Because in my experience, that simplifies drastically both your ability to interact with the data in the cloud through an agent, but also to kind of like future-proof your architecture in the future using open table formats, and that will help you then kind of like pick and choose whatever tools you have. Like I would say, like the first step is kind of like try to convince them to put some, at least some of the data on S3 bucket or GCP bucket or something like that.
Elvis, I don't know if you want to add something. I see that you
Yeah,
raise your
Uh,
hand. Yeah,
yeah,
please.
yeah. I also think this is something that is much more feasible as of recent because of the progress as it relates to like open source data projects, right?
yeah.
So like I think in like Bauplan's case, you guys are using Iceberg and Data Fusion. And so I think these projects having actually hit critical mass. And what I mean by that is like query engines can actually like use Iceberg, right? And so I think this is like something that's unlocked this type of infrastructure because it's a lot easier for you to actually procure it and embed it into your organization because it can meet you where you are. And so I think this is actually only possible as of probably the last 2 or 3 years in practice.
Yeah. And I think like the tool chain is also becoming like better. So it's not a massive undertake to do. And it's getting better like by day, basically.
Yeah.
I hope this answers the question. I think like generally speaking, when you want to bring like AI in your data, you will have like at least like certain concerns around like leaving your agent alone with the data that pretty much like revolve around these three main points. This is the stuff that we see most of the time in production is isolation, as in a way to have the agent able to touch the data, but in a way that doesn't impact production. Data is a bit different in code because data is typically something bulky that lives in the cloud, and you probably have a shared location, and you probably have systems that read from a table that is in production. So if the agent changes something there, that will have like an impact on a number of other, downstream applications that you will have in prod. Um, the ability to audit what the agent exactly does, which is not necessarily simple because depending on how the handshake between the agent and your infrastructure is set up, the agent will have the possibility of access a lot of things in the context or not. And if it doesn't, it becomes a little bit of a mystery box and underperforming, generally speaking. And then finally, rollbacks. So, you want to the best situation you're going to find yourself is the one where you can kind of like leave your agent unchecked and have the agent to really try as many times as the agent can to figure out like possibly complex problems, and you have kind of like the safety that you're relying on a system that you can that can isolate the agent but also undo potentially what the agent does. So these are kind of like the three main things that we see are very important. And once you have like a good way to deal with these, like bringing agents on your data is actually very much something that is within reach.
Ciro,
Yeah.
quick question from the Q&A tool that then copy
Yep.
and paste here for everybody. What breaks first when you let an agent touch production data instead of a human?
I don't know like what break first, but like the general point will be that your system is generally conceived for engineers that are typically well trained and they are, they have kind of like a special skill set on data. And the whole, especially analytics, the whole platform is designed in that way. So you can like count on the fact that people are really thinking before doing stuff. The agent will be a little bit more like as a kind of like caffeinated intern. So it's gonna like it can do a lot of very smart things, but it will kind of like break things while doing that. It's kind of like exploring a space of
Hmm.
possibilities, exploring different. So we see like for instance the pattern of querying in one of the skills that we have that is very popular that is explored data. An agent will run more than 10x the queries that a person does. In just like in the attempt of understanding like a complex complex data sets and how to put them together. So if one of those queries is kind of like drop table, one of those comments is like drop table, now you drop table. So the agent there's the risk the agent is going to be just like breaking things like in this frantic exploration and work. The So what we're building basically is an infrastructure that is built specifically to take care of these problems. Like our deep belief is that you shouldn't do it, but your infra should do it like specifically for you. So you use Bauplan basically to do mostly data engineering workflows. We're now in production with several customers, like and counting. This is a product that is built specifically for people to use like agents in production, and that's really the use case that we serve. What we're going to be doing today is how do we do the entire end-to-end. So Bauplan is, you should think of that as more of a kind of like a lake house where your data is in the data lake, and then on top of that you can run queries, create transformations, do pipelines, do analysis, but the data needs to be put in that lake. And that's where like new products, like new frameworks like dltHub come in handy, as in like the first step of your end-to-end lifecycle is where the integration can be done now in pure Python, which is fully programmable, which is perfect for your AI agent to figure out. So this is a very different world from just like a year ago, where like integrations have been historically like very complicated and very hard to do. And also today we're going to do like the entire full cycle. We're going to take data from someplace in the internet, put it in an S3 bucket using dltHub, and then from the S3 bucket we're going to use like an AI agent to build several different analysis on the lakehouse using Bauplan. This is pretty much what we're going to see, like as a high level. I'm going to be using Claude Code. I don't know, Elvis, are you going to be using Claude Code, or you have another? Okay,
I'm using Claude Code. Yeah.
We're going to be using Claude Code, and we're going to go from just like some source data into Parquet files in S3. And then once they're in S3, we're going to do a safe ingestion of that file, of that data into the data lake. And then once the data is in the data lake, we're basically going to ask the agent to do a number of analysis and come up with several hypotheses to answer a certain question. And then suggest what is better, and whatever wins, we can merge, and we have something in production. That's kind of like the end-to-end workflow. Having said that, if we don't have like any other question, I will jump into the demo and into a deep dive into dltHub and pass it over to Elvis.
Yeah. Do you know if we have any questions, or we're good?
No, for now.
We do.
No, for now.
All right, cool. Yeah. So hey everyone, I'm Elvis. I work at dltHub. We build DLT, which is an open source Python SDK. And the main goal of the library is to just make it as easy as possible to move data. And so we have a ton of like verified sources, and we support a bunch of different data types. And I'll probably give a couple of code samples later so you can see what those look like. But the whole goal is like wherever your data lives, whether it's in some API or in Parquet or in S3, if I want to be able to move it into a data warehouse, it should be pretty easy to do so. And it should also be the switching cost, if I want to switch vendors, should also be essentially zero, right? And so one of the nice things about DLT is that usually in one line of code, you can switch the destination. And so this is great if you're, for example, using Snowflake, and then in the future you want to switch to Iceberg, right? You can kind of future-proof your tech stack. We can go to the next slide. Yeah, and so one of the nice things that we've been working on in the agent setting is most of the services that people are using or pulling data from on the DLT side are actually REST APIs. And so we've actually built a context server. And so we essentially give agents an access to our server, and they can say, I'm working with HubSpot data or Salesforce data, and it can essentially pull context for that particular source. And this effectively makes it one-shot a data pipeline. And so this is really nice because it helps you accelerate your prototyping. We do the next one. Yeah, and so a good example of this is that we actually work with a bunch of data consultants, and they tend to like DLT because usually they have very time-boxed projects and they want to be productive very quickly. And one of our consulting partners was actually able to switch to fixed pricing because they were able to dramatically de-risk essentially prototyping with their customers. And so in their discovery calls, they were literally able to pull up Claude Code and have like a semi-working prototype. And this essentially de-risks the business value, or I guess the business risk for them. And so this has been a game changer, at least in terms of them, because they're able to like have more consistent pricing and have fixed pricing and then take on more clients.
Elvis,
Yeah.
we have kind of a comment, and I'm copy and paste a new question that we got on the Q&A that is related to, I think, Tasman, your client. And the question
Yeah.
is basically say, okay, you went from 2 weeks to 20 minutes. The agent is driving DLT. So what's a new
Yeah.
bottleneck?
Yeah. Yeah.
Uh,
So the
uh,
new bottleneck is actually being able to validate the data that they're trying to load, right? And so that's where like things like Bauplan come in, right? It's like an agent can build a pipeline now very quickly, but it still needs a way for you to deploy that pipeline. It needs to be able to provision itself ephemeral storage. That way it can actually load data and then query that data and see if the pipeline that it wrote actually works. And so right now, usually what you'll do it with like a copilot, like you'll essentially have someone guiding an agent and they can inspect the data for themselves. But we're like working towards this feature where ideally an agent can be given a prompt, write its own pipeline, deploy it, load data, inspect the data that it loaded, all in like a, I guess like end-to-end like feedback loop. And so I think that's what we're building towards now.
Good. And I think we can move to the comment also that is related to like guardrails. Basically, say if you let the agent full permissions to run Terraform, then the entire database could be wiped off accidentally, and the agent aggressively run Terraform destroy. I don't know if you want to comment on that one.
Yeah, less so on the Terraform. Um, we're primarily using agents so that they can like build DLT pipelines. So
Mm.
we usually don't let them touch Terraform. But I think there's a lot of sandbox providers. And the nice thing about DLT being just a pip install is you can run it in a sandbox really easy. So like if you're using like Daytona or Modal or E2B or even just like Lambda, you can just import DLT and start using it. And so I think that helps a lot. And then on the second thing is that you can also use things like, Iceberg, like in Bauplan's case, right? They actually have built these guardrails from the ground up specifically for this type of like access pattern, like being able to like branch and have data isolation and then not have data loss. And so I think I'm pretty excited about the future and the tooling that we're building to kind of make
Thank you.
this more accessible. Yeah.
Thank you for quoting us, and I'm gonna let Ivan know that you also quote like Daytona is gonna be happy, I'm sure.
Yeah.
And Ciro, I don't know if you want to comment on this one.
Yeah, no, I think like in general, like the idea of like the tool chain that brings like agents able to manipulate the cloud is like now in the
Yeah.
shaping. Like the first phase is like, oh, the agent is really good at writing code, which is clearly the case. But you also have like the reason why that is so successful is because you have a very clear workflow and very clear tools around that. So like you have your IDE, it changes files on your local file system. You have your terminal to run it, to try and get the agent try it again. You have Git to travel back and forth in time to create isolation with the branches and so on. Like it's a very clear workflow. And I think like the moment you move this into the cloud and especially in data, like that workflow is not exactly obvious. And there are no tools out there that I necessarily have this as primitives. So this new generation of stuff like it's coming up like us and DLT and the isolation like Modal or Daytona are all around like the all like in general all together are kind of like providing now this new way of doing things that
Yeah.
put isolation as a primitive like in every given step of the way.
Yeah, thanks, guys. We have two more questions. So the first one is about like agents' identities, which is pretty cool. So, what are your thoughts
Okay.
on giving agents actual identities within Bauplan or DLT instead of giving them your credentials?
So in Bauplan, that is definitely a best practice. You definitely want to have an API key. So Bauplan works as a cloud infrastructure. So you basically have an API key, and through that API key, you will be able to run compute at scale in the cloud and to manage data in a data lake that sits on top of your object storage. What you will do is to take like an API key and give it to your agent and set the restrictions and permissions to that agent at the API level. Because like one thing, for instance, you will see is the system that we built that is built upon the concept of data branches. One thing that is very important for your agents to never be able to create any problems that your agent cannot mess with the main branch, which in this kind of like metaphor is the branch that you have in production, is the branch where the data that other system trust live. That branch the agent cannot touch. It can branch from it, and it can ask you to merge, but it cannot drop a table, it cannot modify a table, it cannot run a pipeline over main. And that is something that you decide at the API level. So yes, give identity to your agents.
What's your take, Elvis, on this like philosophical question of like identity of agents?
Yeah, I mean, I think similarly to Ciro, um, we love branches, right? Like DLT is just code, and so being able to like keep using Git and Git
Yeah.
branches is very seamless. Um, on the deployment side, I think it just points back to sandboxes, like being able to have agents run code in sandboxes and then also provision storage in a sandbox way. I think those are kind of the two things that kind of enable
Yeah.
this to actually work in practice within an
Um,
enterprise. Yeah.
Thanks. I mean, the next question is, I think, for
I
us
think that's
at
for you guys.
Bauplan, a very, very interesting one, which is what is about like data copy. And it said, when you explore like multiple hypotheses, will data be copied and become the actual bottleneck? I don't know if Chiro, you want to take this one.
I will defer this to the demo because I'll show you how it
Okay.
works. The short answer is no, we do zero copy, but it was going to be clear when you see it because the
Okay.
copying is so instantaneous that clearly is not an actual copy.
Okay, so very last quick question, and then we move to the demo.
Cool.
IDs, so it's an example with OpenClaw agent. I think it's about identity, so giving his own email, GitHub account, Canva board. The only thing of mine I give it is the MCP read plus write access to my Notion DB. Strongly recommended to create separate accounts for agents for RBAC reasons. So I think it's a good example. Okay, let's move to the demo, and then I'm gonna take we're gonna answer to the next questions.
Hi, man, the floor is
Okay.
yours.
Cool. Yeah, can you guys see this?
Yep.
Okay. Let me move this little zoom bar. Yeah, so typically people start off with DLT using CLI. And so we typically have commands like DLT init, and then that kind of like sets you up with a project. And so this project is empty. I have my virtual environment. I have a couple of slides in Markdown, and then I have my Git, right? And so some of the new commands we've added are very AI oriented. And so a good example is like I can do DLT AI init, and then what ends up happening is, well, it errors, and that's because we check to see what agent you use, and it's unclear because I have a bunch of agents installed. And so in this case, I'll actually run this command so that I can show Claude. But this will essentially initialize like skills. It'll initialize an MCP and set up rules for how to work with DLT. And the nice thing is that once you have these set up, it's like pretty easy for Claude to know how DLT works. But actually, the more recent models actually know the code base pretty well. And so after I do my initial init, I can actually list the skills that are available, or toolkits. We're calling them toolkits because they're actually a collection of skills. And so we have skills for data exploration. We have skills for using the dltHub runtime. And so this is like, I build a pipeline and then I deploy it with the runtime. And then we have a skill for REST APIs. And so a lot of the common use cases are interacting with like Salesforce's REST API. And then we also have a skill for doing some lightweight transformations, right? And so in this case, I'll actually install the REST API skill. And so you see I'm pulling from our servers, and then I'm getting things like adjusting an endpoint, debugging a pipeline, finding a source, validating data, etc. And so we're actually going to use one of these. And so if I go into Claude Code, I can say like, help me create a pipeline. Let's see if this works. Yeah. That pulls data from GitHub and loads it into DuckDB. And I want to fetch the stars that I have. My username is then I do like a type in my username. And then the nice thing is that Claude can start using the skills that we set up. And so one of these skills, find source, for example, can actually hit our server and it can actually pull the different sources that we have. And so in the slide that we had earlier, we showed that we had like around like 10,000 essentially context files for these different sources. And then the agent can go in and actually look at them and then ask me more questions, right? And so I can say, yeah, let's use the REST API pipeline. And then I can also say, I loaded the GitHub token and var into this shell session. Yeah, and then we can just like sit back and watch it go. And so while it's doing this, I actually wanted to pull up a couple of slides here. And so DLT has a couple of primitives that make it really easy to work with different data types. And so the first thing is that we have what's called a resource. And so I can essentially take a function, have that function yield data, and then I can wrap it with this resource. And after I wrap it with the resource, I can actually put it into a DLT pipeline. And so this pipeline is essentially just a destination. And then eventually when you run the pipeline, you'll actually pass in a source. And so this is like the smallest unit. And then the second thing is that we try to give developers a lot of ergonomics around using decorators. And so you can overload a lot of these inputs. And so I can say like, this is my right disposition. This column, for example, is we need to anonymize it, right? And so you can say anonymize true. I can have this run in parallel. And so we're just trying to give the agent essentially like a fill in the blank. That way it doesn't need to figure out like, how do I incrementally load data or come up with its own way of doing like, normalizing schemas or whatever. And then I can say, yes, let's run it. So I'm going to have it run. And then the second thing is that you can actually group resources together into one source. And so I can say like, we have repos, we have stars, and then I'm going to put both of these into a source. And so this might be like a database or something. And then these are both like tables in that database. Yeah, and so you can also, it's regular Python, and so you can have like nested functions. So for example, this is a top level source function with some local resource functions under it. Go to the next one. You can also use REST APIs declaratively. And so I actually think this example is using this. And so the cool thing is that because this is declarative and this is just a typed dictionary under the hood, I can actually have really nice version control. And it's really easy for the agent to write, because it can just traverse this like a type dictionary and see like what the types are. And the goal is just to give guardrails for the agent. And so cool. So it looks like the pipeline finished. It only is loading, for example, one row. And then we have a validate the data. And so I could, for example, say, let's remove the limit and load all the stars, and then start with validating the data. Yeah, and then the next thing I'll try to explain is that DLT is very interoperable with whatever your source is. And so you can pass in a data frame directly. So I can literally make like a polars or pandas data frame, pass it into a pipeline. But we also make it really easy to work with your file system. So you could, for example, point DLT at like a folder that has a bunch of Parquet files or CSVs, and then that can be your input. So what the next one is. Yeah, and once you actually have a pipeline running, we have a concept of a data set. And so I'm taking a pipeline, this pipeline already ran, and so we've loaded data into like Bauplan or Snowflake or Databricks. And then what I can do is I can call this data set function on this pipeline, and then I can actually like do some lightweight validation. And so I can say like, I want to get like the first 100 rows. I can also use IBIS to run some SQL expressions against it. And typically we'll use this whole workflow locally. And so I'll say like, I'm going to fetch like only 100 rows from GitHub, and then I'll load them into my local DuckDB. And then I can use like, for example, Marimo Notebook to do some validation to see if the data that I'm loading is correct. And then eventually, once I want to promote this to production, I can switch from running it with Python to running it with the DLT runtime. And the DLT runtime can automatically switch out the end destination. And so in this case, we'd go from loading it into my local DuckDB into Bauplan, right? Yeah. And so I guess to like summarize, like we're trying to be essentially a platform engineering team for the data community, and then just provide people with the right primitives to work with schemas, to normalize data, to incrementally load it. We try to also make it easy to use the best practices, so like being able to like use secrets, um, and then eventually having this dataset API so you can actually like evaluate the data that you loaded, right? Cool.
Elvis, we have a very
Yeah.
pragmatical question. Thank you so much
Yeah.
for your demo. So are these skills like open sourced? And I think Carlos actually helped like sharing a link, but I don't know if you want to add something about the way that you guys like provide skills to the community and maintain it.
Yeah, so we have a bunch of repos on the org with a bunch of different skills. Um, yeah, I think the high level goal for us is to like have a core set of DLT hub skills that are really, really solid, and then make it
Mm.
really easy for an organization to like overlay their own skills that have their practices right. And so like in the Tasman case, like they have a bunch of skills for how they work as a company. And this is really helpful because if someone initializes, for example, a project with the CLI, and then they automatically are able to pull their company's skills, then this helps the organization actually standardize and templatize their work and how they work. And the nice thing about this is that this makes it really, really easy to onboard new engineers and new people, right? And so, yeah, like there are a bunch of skills on the GitHub that you can just pull up. And then in terms of the sources, we're also working on making it so that people can like submit requests for us to like scrape different sources and then add them to our like LLM context database. But those are pretty easy to use. You can just like hit them directly. Yeah, cool. And so
Nice.
yeah,
Thank you so much.
yeah, totally. Yeah, so I wanted to just close this pane. Yeah, so we can actually see that the AI is done running our pipeline. We pulled 1,800 rows. I've started a lot of repos the past like 10 years. Yeah, and it can essentially tell us about like the metadata, the timestamps, the metrics, etc. And then another nice thing is that I can easily inspect this with the Marimo notebook. And so I have, for example, a Marimo notebook running right here. And so like if I go to my browser real quick, this is what it would look like. I can essentially attach to a pipeline, and then we can do the thing that I was talking about earlier where we pull out a data set. And then once we have the data set, we can actually query a table and columns, and then we can, you know, actually materialize them. So like if I press play, for example, we'll actually go ahead and run this. Yeah, and so in this case, I can see like these are like the stars from last month. So this is a small query, and then I can also easily see like the schema and things, right? But we have the actual larger query loaded into Bauplan, and so that's what Ciro will show. So I'm actually going to switch back to him.
Thank you, Elvis.
Yeah, no problem.
Ciro, I think we have a question for you before we get started. I
Go
think
ahead.
it's a sort of an analogy. That's the way I read the question. So what's Bauplan plan in utilizing like Git work tree to further shorten lead time for huge end-to-end analytics like engineering projects? I think the implication is,
Yeah,
can
we
we?
actually use Git.
Yeah.
Yeah, it's like yeah. So the Git for data that I'm going to show you is effectively an ergonomic metaphor. So you will have a way to work with abstractions that you understand, like branches and merges and rollbacks and commits histories. But like what is happening under the hood is more like it is more in the lake house iceberg world. So there's a lot of work actually for us internally, kind of like understand how much of that is formally
Ciro.
speaking the same as Git. Yeah,
Ciro, I think the mention was to Git work tree. I think it is referring to like parallelization of like branches. So if we have something that is, can you work on parallel or multiple branches with like multiple agents? That's a
absolutely. Yeah,
okay.
absolutely, absolutely.
But
Like that's what is.
It's a
I'm gonna
great,
show you in the demo. Like it's gonna be probably easier for you to see it
yeah.
than anything else. Yeah. Okay, so we take it up where we left it off. So like the we now have some data that through the basically the connector that we just like created on the fly with DLT is in an S3 bucket. So one thing we're gonna do is something like this, basically. this is all we're going to do today. It's like I want to act as a data scientist and analyze the data set of monthly stars. This is where the data is, which is where we just like put it. And then we're going to ingest this data into the lakehouse, and then we're going to ask a question that per se is not necessarily, it doesn't necessarily have like one single answer. So basically, like, like which organization are rising in March 2025, which can mean several things. And so we're asking the agent, come up with different hypotheses of what rising means, and then, run that, do the analysis, build pipelines for both your hypotheses. I limit now here the hypothesis to two just because like in the interest of time. And once you have that, defend your choice, explain why one hypothesis might be better than another, like explain what's the difference. And then after that, we're going to decide which of these hypotheses will become an actual pipeline that we're going to deploy in production. That's the entire workflow, which is typically the workflow you will do like with a data team. Like this is kind of like an end-to-end, is a simplification of what in reality can be a fairly complex project. We're going to do it like just like straight using Claude Code. Before doing that, one thing that I wanted to show you is just like very quickly the ergonomics of the branches. Bauplan is different from DLT. Like it's more of an infrastructure in the cloud. So what you have here is like stuff like this. It's basically like a data platform where you have like your tables, and you can explore different tables, and you can run queries against it. Like, and we provide the whole infrastructure to do that. What is going to happen in this specific case is that you will work revolving around the concept of a branch. So the branches you see here are basically versions of your data lake. You see there's tons of them. That's mostly because like these are kind of like automatically created by different agents that are running right now. But it looks a lot like a Git branch, as in there's a commit history, so that records everything that happens on your data lake, like every operation that changes the status of the data. So like if you import some new tables, if you modify a table, if you run a pipeline, you create new assets, like all that becomes part of your commit history, which is immutably recorded and provides you with effectively a time traveling device. Like if I click on this one here, like on this commit, now I have a hash. And now like the tables that I see here are now relativized to this hash. So I'm looking at the data lake at the time of this hash, right? So this is kind of like the general abstraction. The way you work with it is mostly through CLI or a PySDK. So like, for instance, if I wanted to see, this is kind of like the entire platform, if you want. It's just like, you're gonna like we squeeze this data infrastructure into just like a very few simple comments from your CLI. So if we wanted, for instance, to do what we just did, so look at the branches, we're gonna just do branch ls, and I'm gonna see that now I only have like my main branch. If I want to see all the branches in the world, I'm going to do this, and then these are all the branches that we have open, like in all different namespaces and different users, okay? But like everything you do is basically happens here. You want to see what a branch is. These are the tables in a branch and so on. So like everything you see can be done like through the CLI or through a Python script. I'm going to minimize this for a second. So once we have this, we can just like go and open up our Claude agent and go ahead. So what Claude will do now is loading a bunch of skills that we provide, like you can just like install it as a plugin. Our skills are typically portion of the workflow that can be templatized. So the first thing, for instance, that will be used here is the import of the data. Everything we're going to do, like everything we're doing from now on, is potentially a disruptive operation. Like we might import some data that can drop another table, can replace some other data that we already have in the lake. Like in a production scenario, all these are operations that we run and change the status of the lake. What is going to happen here is that using for instance, the first phase of the workflow, which is importing the data, uses this skill, which is safe ingestion. With safe ingestion, what happens is that your Claude Code will just like create a very simple script like this one. The script will use a client, and we use the client to submit jobs to our cloud executor. It's going to create a data branch. It's going to create a table in that branch, and it's going to import data inside of that branch, and then it's going to validate the import to make sure that the data we imported makes sense. Once this is done, what we will have is basically some new data somewhere that we can query and we can do work on, but it's not in main yet. Like it's not data. We didn't replace anything. We didn't touch the production environment just yet. So we have like this new branch here, and we imported the rows of this new data set under this table that now has in the GitHub Analytics namespace, the name of the table is raw GitHub stars. That's it. Now, step 2, we ask the agent, okay, what do we do with this data? Come up with an hypothesis. So step 2, well, it's going to load another skill, which is explore data. And now it's going to basically just like explore the data and understand what's going on in this data and come up with some hypothesis. How does it do that? Well, once again, in the simple way that every agent does it. Let me minimize this for a second. It just creates another script that uses again the client and runs queries this time to understand. No, this is weird. Okay. It understands like the shape of the data. So now you have like this data explorer script that is going to give you like a report of what the data looks like. Once we're done with this, the agent will run this several times, try to understand what the data looks like, and it comes back with this like, okay, so this is what I found. This is what the data set looks like. This is what the schema is. What does it mean rising? Well, I have two hypotheses. Hypothesis 1, we can think of rising as a way of just like absolute star volume. So you're probably going to get like Microsoft out of this, like as the top one. So it means like cumulatively all the organizations that have the repository and the stars, we do a count. And so this data set, we use this data set to represent what is, like an organization that has like a lot of stars across different projects. Or this one, sorry. Or we have like momentum, like maybe it's a small organization, but it has like one repository, just like very popular in the past month. So these are two hypotheses that we can do. It's like, what do you think? Like few caveats before you decide, with only 1 month, this is a small data set, fair enough. Do you want to proceed? Okay, you can go ahead. And now the system will go from the import phase to creating actual pipelines in two separated branches as parallel analysis. And these two things will happen again on different branches. So we have like a first branch where you imported the data. And then from that, you branch again and you have like hypothesis 1, hypothesis 2. The pipelines will be created and run against the cloud executor. So you could do that at scale. This is a demo and it's a small data set, but like we typically run big data in the cloud for our customers. And what you see here is that once again, the way in which this will happen is by just creating code in your local repository. So here's 2 folders, pipeline H1 momentum, pipeline H2 breadth. Creates like the Bauplan project. And now it starts creating a script that will define the pipeline. And under the hood, what the agent does, it keeps running different commands against our cloud. Right? Like through as CLI commands, or when you want something that you want to inspect as a script, as a Python script that ends up being part of your code. This is a Python script that has been created models.py. I'm going to minimize this for a second, and Claude will keep doing what it does. This is a pipeline. This is an actual pipeline. So the pipeline says, hey, these are the columns that I expect. I want this table to be written into the data lake. So I wanted to materialize it. These are the packages that I'm going to use to create like this pipeline. These are the dependencies. This is the input data. This is my semantics, right? This is my semantic definition. Like this is in the doc strings, the agent will tell you what this table is for. And this is how we get the table. It's just code. So this is going to be run with Bauplan run, which takes this code, packages into containers, run it into the cloud, and writes it back into your data lake. This is the first pipeline. This is the second pipeline, which is slightly different. The semantics here is, this is also an aggregation, but is meant to check different things. It's distinct trend repos instead of just like the total, the single repo that beats everybody else, like in terms of popularity. So if I get rid of all this and I go back to my agent, which at this point is probably kind of done. Yep. So both pipelines are materialized. Both branches are live. So I have now new tables that I can explore in different pipelines, in different branches. And this is the side-by-side comparison. What we get is that there's an agreement on the top 10 in both. So it doesn't really matter that much. Only 3 orgs are different. So we can decide which one is the one that represents better like our kind of like data analysis hypothesis. And these are, this is where it matters. It's just a report of what we think makes sense. So the recommendation is to actually deploy H2 instead of H1. And this all we have. We have a new branch that we can merge into main. And then we can get rid of all the branches that we created to do explorations. What does it mean like practically when you see like, for instance, through the UI, which I think is to a certain extent like a simpler way to at least like check what happens. And we now have like several new branches with new tables that don't exist in main. Like an example would be in the first branch we created the import. The last commit that we have is import this iceberg table and create this new table that is called like this. So can I run a query against this table? Of course I can. I can do select star from this, commit 5. This is a new table that I imported, the one that we used to formulate our hypothesis. Does this exist in main? Like in my production environment? Not yet. So it doesn't exist anymore. Like it doesn't exist yet. Once I ask my agent to merge, okay, merge H2. We will have the publication in production of both tables that we created, the one with the raw data and the one with the analysis. And now all this will become available for the first time in main to your downstream applications. We go back here, we run this query again, 1 sec. This does exist now. Oh no, we made a terrible mistake. We didn't like this at all. It was a stupid idea. We shouldn't have done it. Travel back in time, run the query again. Doesn't exist. So like the agent is isolated all the way in every step. You can travel back and forth like with Git. You're secure to lead the agent to do multiple hypotheses, to do iterative work on your data without ever worrying about it. And all you have is a bunch of scripts that you can always commit to your GitHub repository and just like check and inspect like you usually do with your code. That's in a nutshell is what we provide. Matt?
So we have a question and
Yes.
a comment and a very interesting like conversation about like the semantics. So the comment is related to when you have like multiple approaches to data, definition of success is so excellent. And so I think it's a very, very nice way, the way that you put it. I think that's a comment that they were getting so that you have a definition of success.
Yeah,
And
especially
then
for entities, like you will have like the problem that the conversion rate for the, like for the finance team is a slightly
Exactly.
different like definition than conversion rate from the product team and so on,
And
yeah.
that's a kind of like
Yep.
conversation that we're gonna have in now at this time, like live on the chat. But the question is mostly related to
Yep.
who is in charge of the decision of promoting a branch or the other. So is it human? Is it the agent? Anyone?
Right.
Okay.
Right.
Can you let the
Well,
agent merge? If yes, what, when, and how?
well, it depends on how adventurous you feel. Yes, ideally what you have here. So from a broad perspective, what I want you to think about this is your whole data platform, your whole data practice now is just like software. Because basically what you just said is there's branches, there's code, there's data. They all fall under the same abstractions. And we're just going to work on this like we work on any other software project, which means that it's up to you to decide how you can work with the agent when it comes to merging. I can tell you what customers do. Typically right now, not everybody is super keen to let the agent make a lot of decisions completely independently. So in many cases, especially when it comes to explorations and creation of new pipelines, typically we have a person who comes in and kind of reviews a PR of what the agent did over a data branch and decides whether to merge or not. We do have other customers that do automated merge, especially close to the ingestion piece, using like write, audit, publish type of design, where you basically have the agent creates a branch, imports some data, then we run a bunch of quality tests. And if the tests are passed, we feel comfortable in letting the agent merge. If they don't, you have the branch kept open for further inspect and debug. It kind of depends on how strict you want to be your data CI/CD to a certain extent, but you have like a number of possibilities.
Great. Let me pull up one more question that is on the Q&A. On Q&A.
Also, I was workshopping the work tree question. So Chair, they're essentially trying to have it so that you have a really nice developer experience where you like make a work tree and then automatically get like a Bauplan branch or a Bauplan branch. And I think that should already work, especially if the branches aren't like if you have the CLI scoped to the repository, then I think you can actually just do it with the shell function. Like create work tree, in that work tree, like I want to create a new branch based on that work tree name at Bauplan, and then the agent is like free to do its own stuff.
Yeah, the agent like will
Yeah.
just like use the shell command to do that. But like when you
Yeah.
create a branch, you're basically creating like a version of a bunch of iceberg tables in your S3 bucket. What people typically do is they attach a data branch with a Git branch.
Yeah.
They tend to like the normal workflow would be like a agent creates like a Git branch where you're gonna write like, I don't know, hypothesis 1 or hypothesis 2, commit that code to my Git branch and associate that Git branch with a data branch or a number of data branches that are created in the cloud.
Yeah.
Elvis, thank you so much because I kind of forgot of it.
Yeah, I was looking into it.
Of a word Twitter and apologies, Elvis. Thank you, Elvis. So we have two more questions. One is say kind of an unrelated question. Bauplan itself, if I understand it correctly, is also like a query engine.
Yep.
How does it how does it work in terms of like query engine? So it requires like a lot of resources, how the resource allocation works. So for example, a complex like logic with like 100 of like gigabytes, if I have to query like a sizable, table, for example. I think that's the way I understood the question at the very least.
Yes, we do provide. So Bauplan is a managed infrastructure. So like optimization of queries is 100% on us. So you should think of this like the way you run a query against Snowflake or Photon or managed Trino or something like this. There's several places where we do optimization when it comes to pipelines specifically. So, when it comes to pipelines, you will have like also, a number of optimization around like caching data across like different pipelines or across different queries that are run by the agent. One thing that we notice is that agents tend to run queries that are not necessarily the same, but they kind of rhyme. So you will have like if you have two agents exploring the data, there's a good chance they will kind of like run queries that scan the same data over and over. And so we make an effort in making sure that that doesn't happen. So like we can cache some of the data and make it available to other queries for other agents, so you can have like a very seamless experience. There are some best practices that you want to keep in mind, like to use polars inside of your Bauplan functions instead of pandas, just because it's faster, or don't do select star. But these are kind of like normal I would say that they're kind of like very normal, very basic optimization that every decent data engineer they're second nature.
Thanks. I think Elvis is like, uh, uh, I don't know if I think he has to move to a different room. So let's take, okay, so he's back. So let's take one more question and I think we can wrap it up. So the very last question is about, like Python versus SQL for agents. So what's pro and against like using Python? What's your take?
As opposed to SQL.
Yeah, so when it's better to
Oh,
use
I see,
like,
I see.
yeah, okay.
Well, it kind of depends. Like, so like SQL is just limited to certain things. So I think like Python is like obviously is a more expressive language. So honestly, like the agent in this case, like can do a little bit of both in Bauplan at least. Like if you want to run a query, the agent can definitely like if you take like for instance like take this, right? So if you take something like this, we can easily think of this step in a pipeline as a step that instead of using polars can use DuckDB and run SQL inside of instead of like polars code, um, which like has some advantages. Like SQL is probably more widespread as a language, is easier to maintain and to read for most people. There's entire populations like analysts that are like more used to it. Uh, but ultimately, once you want to have like something that is a bit more complex, like for instance, the ingestion, where you have, imperative logic, you create a branch, you create a table, you import the data, you merge this if and only if. Python has an expressiveness that nobody else, that SQL doesn't have. My dystopian answer ultimately is if you kind of have Claude Code writing that for you, at a certain point, how much does it matter for you, like to have like Polar's code versus I don't know, like it seems that it becomes like less important for everyday work. Like
I don't know, Elvis, what's your take? And then we're gonna wrap it up.
Sorry, I was trying to answer a question in the chat.
Okay, okay, okay.
Yeah,
Um, so the question was about, SQL versus like Python for agents. So when do you think, I mean, what is the argument like pro or against like
oh, I see.
Python superiority for agents?
Yeah, I mean, I think agents are really good at writing Python. And so on the builder side of things, I feel like our goal should be to make it so that we can build nice query planners, right? So like ideally I can
Hmm.
get, a set of Python functions and then kind of decompose them into like a nice query that runs as SQL. That way it can run against your data warehouse. And it feels like that's what you guys have been trying to do as well. And so I feel like it's more on like the tooling side. It's like if we can build
Absolutely.
these nice query plan builders, then agents can still use Python and then interop with like other parts of your stack more easily.
Absolutely.
so
So,
one last thing is like if I had to explain Pablo in one sentence to my tech lead, what would I tell him? You can tell him this is data infrastructure that is built for agents specifically, so you can have all the agents that she wants running on his data stack and still be able to sleep at night. That's pretty much what we do.
thanks. So thank you so much, Elvis, and thank you, folks, for joining us, and thank you for the questions. I think we had a very interesting like chat. Feel free to reach out to us. We are available to continue this conversation anywhere and in any channel you prefer. Stay tuned because you're gonna receive also an invite for our like following webinars that are gonna take place in more or less like 1 month from now. So we're gonna be in touch. Thank you so much.